Bismillahirrahmanirrahim. Assalamu alaikum, students. I hope everyone will be good. This is Sir Shakil from A-Level Physics, and today we are going to discuss about vectors from AS syllabus, and this is from Unit 1, and this is Part 3, and actually this is the last part of Unit 1. The first two parts are already shared in the YouTube channel, so you can look for them as well. These three parts will cover the whole AS syllabus for Physics 9702, both for MCQs and theory for Chapter 1. Okay, now let's start with the vectors. So first of all, I have to tell you about the significance of vectors, that how significant these vectors are in your A levels. So first of all, it's very important topic. As why it is important? Because its concepts are used in many A-level topics, such as in kinematics and in dynamics, in moment of force, in work power energy, and in electricity. And it is both in MCQs and in theory. That's why this topic is very important. Even in A2, this topic is going to be used. Okay. First of all, we have to see what is vector. As you know, that vector is a quantity that can be expressed by using magnitude, unit, and with direction. For example, displacement, velocity, acceleration, force with all its types. Let's say friction, upthrust, air resistance, tension. All these are types of forces or vectors. Momentum, then electric field strength and gravitational field strength. These are the vector quantities. Okay, next we have to see that how we can represent a vector. So there are several ways to represent a vector. The first one is symbolically. So symbolically we use bold letters. Let's say force is represented by F and velocity is represented by V, and this is a bit bold in its presentation. Then second is numerically. So we can write force as 20 Newton to left. Like numerically, you are giving its magnitude, its unit, and its direction. Velocity is 25 kilometer per hour to east. Okay, the third presentation is graphically. So graphically, we represent the vector with a line and with an arrowhead. The length of the line represents the magnitude or size of the vector. Like the longer the line, it means that the magnitude of vector is larger. Then the arrowhead represents the direction of the vectors. So let's say if this vector represents 10 meter per second, so the arrowhead actually represents the direction. So we say that it is 10 meter per second towards to x-axis. Okay, next thing is how we can add vectors. Unlike scalars where you use simple arithmetic rules like 2 plus 2 is 4 and 2 minus 2 is 0, but over here, as in vectors, the direction is important. That's why you have to follow certain rules to add the vector. So let's have an eye upon them. First of all, we have to look what is the resultant vector. A resultant vector is a vector that represents combined effect of many vectors. Then we have to look for how many cases and examples are there for the resultant vectors. So let's look upon them. Okay, first of all, it is when both the vectors are acting in same direction, so they have zero angle between them. So we just have to add them. If the vectors are having angle of 180 degree or they're in the opposite direction, we have to subtract them. Very simple, first two cases. The third case is when the angle between the two vectors is 90 degrees. So we say it is a perpendicular vectors. So what we have to do to find the resultant when perpendicular vectors are there, we will draw the vector triangle, then we will use Pythagoras theorem to find the magnitude, and we will use trigonometric ratio to find the direction of the vector. Okay, number 4, if the angle between two given vector is such that it is more than 0 degree but less than 180 degree, it can have any value like 10, 20, 30, 40, 50, 60, 70, 80, 90, and then till 180, like not 180, but less than 180, then how you can find the resultant? These are actually the most important questions. For example, over here, F1 and F2 and angle between them is 45. Over here is F1 and F2 and angle between them is 120 degree. Okay, so how to find the resultant? There is a fixed process that you have to apply. The first one is you have to draw the vector triangle. Then you have to use cosine rule for finding the magnitude, and you have to use sine rule for finding the direction of the vector. I hope you are aware of sine rule and cosine rule. Okay, a big question comes over here, how to draw the vector triangle. Like in the first method I've written, you have to draw the vector triangle. So how to draw that? Let's look upon that. Okay, so let's see what are the steps to draw the vector triangle. So the first step is you have to draw one of the given vectors. Let's say the diagram, 100 Newton is the first vector, 80 Newton is the second vector, and 60 degree is angle between them. Okay, so how to proceed with it? So first point is draw one of the given vectors. So what I'm going to do is I'm going to draw 100 Newton. You can't change the direction. You have to draw the vector in the same direction. Now, the second is you have to draw a second vector such that tail of second is touching head of first. This is known as head to tail rule. So second vector, you have to draw it like its tail is meeting head of first. So this is your second vector, and you can write 80 Newton over there. Now for the third thing, you have to draw the third vector, which will be the resultant vector, such that its tail meets the tail of first vector and its head touches the head of the second vector. So let's make that. So this third vacant side is actually the resultant. So look, the tail of resultant is meeting tail of first, and the head of resultant is meeting the head of second. Okay, now number 4, you have to make the angle inside the triangle as it is given in the diagram. So let's do that. This is the most tricky part actually. 60 degree is between 80 Newton and 100 Newton. So let's say if I extend this line of action of 100 Newton, so actually this angle was 60 degree as you can see over there. So now if this is 60, so how much will be this? Keeping in mind one thing, that whole of this angle is 180 degree. So this angle will be then 180 degree minus 60. So it will be 120 degree. So it means that over this angle will be 120 degree. So you know got the angle. And now what you have to do is you have to use cosine rule. You have to apply cosine rule for the magnitude of R. So what is cosine rule and how we apply that? Cosine rule is like a square equals b square plus c square minus 2bc cos a. So let's apply it over here. R square is 100 square plus 80 square minus 2 into 100 into 80 into cos 120. And then what you will do is you will simply take its square root on both sides and you can get the value of R. So you'll get the resultant. So that's how you find the magnitude of a vector using cosine rule when the angle between them is between 0 and 180 degrees, especially not perpendicular. Because in perpendicular, you're going to use Pythagoras theorem. Okay, let's move forward to the next example. And this example is actually the perpendicular vector example. So let's say the two vectors are acting at perpendicularly to each other. So 10 Newton and 20 Newton, and angle between them is 90 degrees. What you have to do is you have to find magnitude and direction of the resultant vector. So what method you will adopt? The same method. You have to arrange the vectors according to head to tail rule. You have to draw the resultant. You have to draw the angle 90 degree, and you have to use Pythagoras theorem. So if we can make this diagram again. So first of all, you have to draw the first vector. So I'm drawing the first vector, which is 10 Newton. Then you have to draw the second vector such that its tail is coinciding with head of first. And this is like 20 Newton and the angle is 90 degree over there. Okay. Now what you have to do is you have to draw the resultant. So this is the resultant and this is the angle. So as it is a 90-degree angle triangle, it is a right angle triangle. So we will be using Pythagoras theorem to find the magnitude of its resultant. So we have to use Pythagoras theorem. Okay, so let's use the theorem. Its hypotenuse square is adjacent square plus opposite square. R squared is F1 squared plus F2 squared. Simply put the value, take the root, and you got the answer. For direction of the resultant, you have to find the angle of the resultant with any of the two lines. So for that, you have to use trigonometric ratio. And you know that sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. So whatever value you have to use, you can use that and simply take inverse of that. So that's how you can find the direction. Moving forward, there is another example. This is an object on which two forces are acting. One of the force is 25 Newton and the other force is again 25 Newton, and they are acting at an angle of 90 degree. So you have to find the magnitude and direction of the resultant. So what you have to do is you have to arrange them and then you have to find their resultant and angle. So do it yourself, pause the video, solve it, and then check your answer. Okay, the next thing that we have to do in vectors is finding the magnitude and direction of vectors with angle between 0 and 90 degrees. So that's again the same thing. Let's say 20 Newton, 10 Newton with angle 60 degree is there. So we will not be making the second one actually. Okay, so what method you will be using? Again, you will be arranging vectors in according to head to tail rule. You will be using cosine rule or sine rule to solve this question. So let me draw the diagram for you. First, you have to draw 20 Newton, and then you have to draw 10 Newton. So 10 Newton like this. And again, the angle, this angle was 60 degrees. So it means this angle is 120 degrees. It's actually the same question as we have done before. So this is your resultant. So you can use cosine rule to find the resultant. And for angle, you can use sine rule. So over here, this is for the previous question. So you can use sine rule, this is the sine rule. And you can use this rule to find the angle. So this is A, B, C. So these are capital are the angles. Okay, moving forward. This is an example. So we have to solve this. So let's solve it. Three vectors are there. So first we will see that this 5 and 20 Newton are opposite to each other. So we can say that this is 50 Newton, like 20 minus 5 is 50. And then this is 40 Newton and it is making an angle of 90 degrees. So what you'll do is use vector triangle and Pythagoras theorem. So I hope you're aware of this as we have already done. So you can just solve it. And its solution is over here. So you can just pause the video and you can look into this solution. Answer is written at the bottom. Okay, moving forward, we have to do some more question from the past paper. So let's say this is the velocity vector diagram for aircraft heading due north. And let's say this is the aircraft which is moving and then wind blows at an angle of 45 degree with the horizontal axis. So the wind speed is 36 and the aircraft speed is 250. You have to draw an arrow on figure to show the direction of resultant velocity of the aircraft, and you have to determine the magnitude of the resultant velocity of the aircraft. Okay, so now what we can do is if I draw it on this side, so this is the aircraft speed, which is 250. And then the next thing is that the wind is blowing this way. I have attached tail of wind with head of the aeroplane velocity. So this wind is actually 36 meters per second. And now we have to look for the angle. As you know, this is 45 degree. So this alternate angle would also be 45 degree, but we have to use the interior angle. So as the whole of angle is 90, so this angle is 90 minus 45. So this is 45 degree. And then finally, you will draw the resultant from tail of first to head of last. So this is your resultant velocity. So part one is done. So you have to find the magnitude of the resultant velocity. So as you know, two vectors and angle between them is given. So you will be using cosine rule. So use cosine rule, which is like v square is 250 square plus 36 square minus 2 into 250 into 36 cos 45. So then you can simply take its root to find the value of resultant velocity. Okay, similarly, there is another question. These questions are very important. Let's say there is a boat which is moving with 3 meters per second at an angle of 60 degree with the river bank. Then water is flowing parallel to the river bank with 1.8 meter per second. What you have to do is you have to, on figure, draw a vector triangle or scale diagram to show the resultant velocity of the boat. So you have to draw it on the diagram. So we'll say that, okay, the boat velocity is this, and then simply arrange the tail of water with head of the boat, right? So this is like 1.8, and then the resultant velocity is from tail of first to head of last. So that is the resultant velocity. And then we have to talk about angle, as this angle is 60 degree. So we'll say that this angle would also be 60 degree. Or not this angle, but this angle, because this is like Z. So this angle is 60, so this angle would also be 60. So this is actually 60 degree angle. So now you have two values like 3 meters per second, 1.8, and angle between them. So what you will do is you will use cosine rule. And when you apply cosine rule on it, it will be v square is 3 square plus 1.8 square minus 2, 3 into 1.8 into cos 60. So you will be taking its root. So that's how you can find the velocity. Moving forward to the next topic, which is vector arrangement and mathematical equation. This is important in MCQs. So all the vectors are arranged, the vectors which are arranged in head to tail rule are always added. And the vectors having its tail with tail of the other and head with the head of other is called the resultant. So let's look in this diagram. A is the first vector and B is the second vector and C is the third vector. If you look, A and B are arranged in head to tail rule, right? Like if you look over here, for this is head of A and tail of B. So they're arranged in head to tail rule. That's why you add them, A plus B equal, and then tail of C is with tail of A and head of C is with the head of B. That's why C is your resultant. So it's equal to C. Then there is another thing which is known as negative vector. Let's say this A is the vector pointing to your right. So its negative vector will have the same length, but acting in opposite direction. B is going this way, so its negative vector will have the same length, but in opposite direction. C is this way, so its negative vector will have the same length, but in opposite direction. Now, we have to solve a question. An aeroplane can fly at a velocity x while moving through still air. When flying in the wind, the aeroplane's velocity relative to ground is y. Which vector diagram shows the magnitude and direction of the wind velocity w? So look, the aeroplane is going this way. And then, of course, wind will be blowing this way. So these both are arranged in head to tail rule. So that is fine. And then this side is actually the resultant velocity. This is the resultant. So this seems to be correct because x and w both are arranged in head to tail rule and y is the resultant. So this seems to be correct. But let's just look on the others. So this is x and wind is blowing this way. So this is not possible. Like wind is going this way, aeroplane is going this way. So how it is possible that the aeroplane starts flying this way. This is not correct because wind and aeroplane, wind W and aeroplane X are actually the vectors which you have to arrange in head to tail rule. So wind W and aeroplane X should be arranged in head to tail rule, right? Okay, so it means that your answer is A. Moving forward to another question, if you look at this, two vectors are given, X is pointing this way, and if you look on Y, that is pointing this way. They're saying that if X is Y minus Z, which diagram will represent Z? So now here comes a thing, X equal Y plus minus Z, because you always add vector, right? So this is the way, or you can say that this is like Z equal Y minus X, right? So when Z is Y minus X, it can be Z equal Y plus minus X. So this is the thing. You have to look for this minus X. So minus X is a vector having same length but opposite direction. So it means that you have to consider these two vectors, right? Okay, so like this is your vector Y and this is your vector negative X. You have to arrange them in head to tail rule. And then the resultant is this way. This is resultant. So A seems to be a resultant. Like you have to arrange the given vectors according to head to tail rule, and then you will look for the resultant present over there. Okay, just look at this diagram. Vectors P and Q are drawn to the scale. So P is heading this way, and if you look on Q, that is heading this way. So which diagram represents P minus Q? P minus Q. So it means that P plus minus Q, it means Q would have a negative vector like this. So actually you have to draw this. Okay, now again, like if this is P and you just draw negative Q on it like this, so then obviously you will have the vector as this. So this is your resultant vector, which is C. So C is the vector which is pointing in the same direction. Moving forward to the last topic, which is very important, resolution of vectors. Like resolution of vector is actually a process of splitting a vector into its components or parts, and those are X and Y. So that is known as vector resolution. For example, this is X-axis, this is Y-axis, and this is a vector F with an angle theta over there. So what we are going to do is we're going to resolve it in a horizontal component, that the part of vector which is acting along X-axis, and then we are going to convert it into vertical component, that is the part which is acting along Y-axis. So how to do that? First of all, you have to see that this component which will be acting along X-axis, that is adjacent to angle, that is always cos, F cos theta. So this is equal to F cos theta. And the other component that is acting along Y-axis and that is perpendicular to the horizontal one, that is F sine theta. So it means this is equivalent to F sine theta. So adjacent to angle, one important hint over here is that any component that is adjacent to angle is always cos component. Like adjacent to this angle is always cos component. I am talking about this one. Adjacent to angle is always cos and the other one is always sine. Okay, now let's find some horizontal and vertical components of the vectors. So let's say this is 50 Newton at an angle of 30 degree. So what you will do is you have to like resolve it. So this component which will be along X-axis, this is cos. So we say this is 50 cos 30. And the other component which will be along Y-axis, it will be 50 sine 30. So you'll just calculate these values using the calculator, like 50 sine 30. This will be vertical component. And 50 cos 30, this will be horizontal component. Okay, now let's look upon the next one. Next one is 25 meter per second at 30 degree. So this is 30 degrees. So when you resolve it, so I told you that adjacent to angle is always cos. So this will be cos now, 25 cos 30. And the next one, which will be at right angle to it, it will be the sine one. Okay, so actually the sine one, like this will be the sine one, like 25 sine 30. So over here, 25 sine 30 will be your horizontal component. And 25 cos 30 will be your vertical component because it is vertically arranged. Okay, now for this one, you can pause the video and you can do it yourself, and then you can play it to check the answer, right? Okay, so now when you resolve it, this is angle, so adjacent to angle is cos. So this component would be 100 cos 45, and this component will be 100 sine 45. So that's how you split a vector into its two components. Okay, the next thing is another type, which is finding the resultant vector using given rectangular vectors. Like the rectangular components are given 90-degree angle, and you have to find the resultant vector. So resultant vector is like in between them. So you have to find resultant and you have to find the angle as well. So what you'll be using is you'll be doing the vector triangle method. And as this is right angle, so you'll be using Pythagoras theorem. So you can try it yourself. You can go back in this video to look for the case in which angle was 90-degree and we solved them. You have to arrange them according to head to tail rule. Like this is 50 Newton and the other one is 60 Newton and angle between them is 90-degree. So then this third one, the third side will be your resultant, which you have to find, and this is the angle which you have to find. So as it is a 90-degree angle triangle, so for magnitude, you will use Pythagoras theorem. So for the magnitude, you will use Pythagoras theorem. And if you want to find the direction, so for direction, obviously you have to find the angle theta. So you have to find angle theta of F with 50 Newton. And for that, you will be using trigonometric ratios because this is a right angle triangle, right? Let's move forward to another question, another type, which is finding one component when other component and angle are given. Let's focus on this question. Suppose F cos theta is 20, which is given, and 60-degree angle of resultant force is also given, and you have to find F sine theta. So how you will do that? So the thing is, over here, for F sine theta, you don't know the value of F, but you know the value of angle. So it means that you have to find the value of F. So how you'll find the value? Like this is F cos theta is 20. So F cos 60 equal to 20 and F is 20 over cos 60. So when you will do this, when you will solve this, it is like 20 over cos 60. So you'll get the answer of 40. So this force is 40 Newton. And now you'll be putting this value over there. So it is 40 sine 60. So when you will do 40 sine 60, you will get the required answer. That answer is 34.6. So this is 34.6 Newton is the value for this F sine theta. Now, going to this second question over there, the Fy is given and the angle is given and you have to find F and you have to find Fx. So now you know that Fy is F sine theta over there. No, it's not f sine theta. It's f cos theta. Why? Because this is adjacent to angle, and adjacent to angle is always cos. So fy is 60, f you don't know, and cos 30. So now it is 60 over cos 30. So you can find the value of f. And that value comes out to be it is 69.3. So this F is 69.3 Newton. And then if you want to find Fx, that is F cos theta. So you just figure out the value of F, which is 69.3, and angle is already given to you, cos 30. So you will simply, oh, sorry, it is not cos 30, but it is sine 30. So this one is sine. So this will be sine 30, and you got the value 34.6. So Fx is 34.6 newtons. Cos adjacent to angle is cos now, so that one is F cos theta, and the other one should be F sine theta. Then. Moving on to the next question, effect of angle. What is the effect of angle of vector upon the value of the components? Let's say over here 20 Newton is acting along x-axis, so it means that its angle is 0 degree. And when you look in the next case, it is like okay, let's talk about this case over here. The fx or f cos theta is actually 20 Newton, and fy or f sine theta is 0 because there is no force that is acting along y-axis. When you look on the second diagram, it is like 20 Newton at an angle of 30 degrees. So how you solve that? You'll say that like how much is fx? That is f cos theta over here. So this is 20 cos 30, right? And when you do that, it is 20 cos 30. So the value is 17.3. So Fx is 17.3. Keeping in mind, previously it was 20. And what about Fy? It is F sine theta. So that is 20 sine 30, and that is equal to 10 Newton. Okay, now let's talk about this one in which that force is 20 and angle is 75. So we will say that Fx is F cos theta. So it is 20 cos 75. So you have to find how much is the value of 20 cos 75. That comes out to be 5.17. So this is 5.17 Newton. And if you talk for Fy, that is F sine theta, that is 20 sine 75. So you will get the value as 20 sine 75 gives you a value of 19.3. So Fy is 19.3 Newton. And the last one is F is vertically. So we say that Fx, which is F cos theta, that is actually 0. Because you know that like 20 cos 90. So cos 90 is 0, so that is 0. Okay, so that is actually 0. The value of 0 is there. And then for Fy, it is F sine theta. So you know F is 20 and sine 90. Sine 90 is 1. So 20 into 1 is 20. So now, as you increase the angle of the force with x-axis, as you keep on increasing the angle, 0, 30, 75, 90, what happens to Fx? It was 20, then 17.3, then 5.7, and then 0. It means as you increase the value of the force from x-axis, its horizontal component or x component starts decreasing. But on the other hand, if you look upon vertical component, so it was initially 0, then it becomes 10, then 19.3, and then 20. So we say that its value is going to be increased. So summing it up, this is x-axis and this is y-axis. So if you are moving your vectors towards y-axis, if you're moving it towards y-axis, then what's going to happen? Like you're going to increase the angle. If you keep the force same and you're going to increase angle, then F cos theta is going to decrease, while F sine theta value is going to increase. So that's the thing which we have discussed. So thank you very much, students. Like you have watched the video very carefully. So what you have to do is you have to solve the worksheet that is shared in the group, shared in WhatsApp group. So you have to solve that sheet, and then you have to contact me in case you are not able to solve any question, right? So this was the part 3, and like the unit 1 video lectures are divided in 3 parts, like part A, part B, part C. So we are done with all the 3 parts. So if you want to watch the videos of first 2 parts, you can go in the WhatsApp group. The video links are over there. And one more thing is that you need to subscribe to my channel, because what I will be doing is I will be uploading all the video lectures in my channel, and I will be sharing all the solved worksheets, solutions over here as well. So if you subscribe, then you know that what can happen, you'll get that video instantly. You don't have to wait. And it's really important that in these 2 years of your A levels, you have to put your all energy so that you can grasp maximum concepts and you can secure good grades. So see you again in the next video of kinematics. So next videos are, there are going to be 3 videos again, and one will be for equation of motion, the other will be for projectile motion, and the last one will be for the graphical analysis of motion.